All right, how's everyone doing today? Um, so today we are going to be starting our discovery of logs, which we kind of have been doing because as you learn through today's lesson, um, logs are really just exponents. And it's just another way to write exponents and to see exponents. So we're going to get some practice with this. So this video should hopefully be a little bit shorter than a normal lesson. Um, and it's kind of one where you follow along and you really just have to practice and try these and check your answers. So, like normally, right, as you go through this, make sure that if you're understanding it, you can kind of speed through it a little bit. Um, if you're not getting it, pause, replay the video, replay the parts that you need, and then you can always just, you know, shoot me some emails, ask me some questions on the material that you're not getting. Or again, it's just one of those things that you just have to continue to practice with some homework, and hopefully it starts to begin to make some sense. This is day one of three of learning some logs and working with logs. So again, today you're going to need to open up to this page in our notes. All right, so it's 6.3 converting day one. So it's going to look like this where you have three warm-up problems. All right. So whenever we do warm-ups or I ask you to pause, again, just like normal videos, pause and really try it like you were in class to see if you're getting stuff and understanding it. So all right, for the majority of these logs, especially for today, we're not going to use our calculator, but if you want to have that out to the side, there are a couple times where we just evaluate logs to make sure that we understand and are getting certain things. So wouldn't be a bad idea to have your graphing calculator out or flip through Desmos to type through some of these values. So let's get started right here. So the warm up, I'd like you to pause the video and I want you to try this. All right, shouldn't take too long. And then after you get through C, play the video and let's see what's going on. All right, here we go. So 2 to the x power equals 8. So again, to solve for this, you're saying 2 to what power gives you 8? Well, so you're thinking 2 times 2 times 2, which would be x to the third power. So x would be 3. B, 2 to what power gives you 16? So this would be x to the fourth power, because 2 times 2 times 2 times 2 is 16. So it's x to the fourth power. And now, and I'm sure you sat here and you're like scratching your head, like, what the heck? Right? 2 to what power gives you 10? Well, clearly, right, if you think about 10, 10 is between 8 and 16. So you're like, is it x is 3.5? Not sure. All right. And what you end up getting is you get into this like weird little pickle. So if you're like, oh, I don't know. So if you're even pull out your calculator and test this out, 2 to the 3.5, you're like, oh, that's 11.3. So you can keep playing around. You're like, all right, 2 to the 3.25, right? And you start kind of getting closer and closer. But notice that as we start developing our math skills, not everything is going to be sunshine and gumdrops and rainbows. And this is where we have to have another way to solve. So a problem like this, you're like, I'm not sure what it is. Well, that's what today in logs are going to help us figure out. Okay. So by the end of the video lesson today, again, we want to be able to do a couple things. Number one, rewrite exponents as logs. We're going to rewrite logs as exponents. So we're going to go back and forth because exponents and logs are both really the same thing. It's just another way to observe or see those things, all right? Then we're going to do something called evaluating. Evaluate means basically tell me the numerical value of the log, all right? We're going to simplify logs. So we're going to take a larger log expression or an exponential expression, and we're going to want to simplify it into a more condensed version. And then at the end, we're going to solve basic logic equations, right? So we're going to introduce what a log is, work with logs, convert some logs, and then start to solve. And you're all going to kind of notice a pattern that because logs are exponents, and we spent all this time doing exponents at the beginning of the unit, we're actually always going to be converting logs back into exponents and solve them that way. So really, the beginning of this lesson when we are rewriting more so this log as exponents, this is going to be huge. All right. Being able to convert these back and forth is going to be huge because that's what we always want to do. Anything new in math, we always want to convert back to something that we are very familiar with. And what we're very familiar with is exponents. You spent all of math one, math two, and math three working on them. So let's take something new and bring them back to something that we're familiar with. So let's take our calculator, and I want you to just get some practice finding these things in your calculator and making sure that you're getting the same value. So number one says log 20. So now I'm going to intentionally start hitting. So first thing, turn on your calculator. And on the left-hand side, you're going to hit this log button. You see this LOG. So we're going to hit log, and then we're going to type in 27. You can close your parenthesis or not, and hit enter. So you should get 1.4313. So logs, as we're going to eventually see, logs are exponents. This number actually is going on and on and on. So we're going to round. So when we write our answer, we're going to say approximately, all right, 1.43. And we always want to make sure that in this class we round to 2 decimals. Oops, move that. All right, so we're always rounding to 2 decimals. So from here on out, it's always 2 decimals that we want to round to. All right, now, so that's log of 27. Now the next one we want to do, you can either clear it out, I'm going to clear that out. Now I'm going to do ln. Now ln, right, is a log, but this is actually, and we're going to see what this is actually called natural log. This has something to do with e, and we were talking about e the last class that we had together. E and natural log, those two have something to do with each other, but figure out where natural log is. So if you remember, down below log, all right, if you look, there's ln, and if you remember, we hit that before because that's where we got the e to the x power. So we'll hit ln, and then we'll go 3 divided by 4, and you should get this in your calculator. So we're going to get approximately negative 0.2, notice 287, so we're going to go to 9. Again, we want to just always simplify and round to 2 decimals. And again, right now, it's just getting familiar of where these buttons are on our calculator when we start using it. And then here we go, red log, -6. All right, hit enter, and oh, non-real answer. So this is going to be interesting why that is. So non-real, and you're like, non-real, what does that mean? All right, so what we would say non-real, really I would write no solution. All right, and this is going to be huge, no solution. Why is that? So we'll come back to this no solution, right? Why that is, and how does that actually work? So, all right. So if you got all these, let's continue on. So let's get to a little bit of notes. Logarithms or logs, all right, are the inverse or opposite. Remember, inverse means opposite of exponentials, and they're written as follows. So if you notice on yours, it's a little tiny, I apologize, but I really like this, this little visual right here. So this is what you're familiar with, right? You are very familiar with this right here. 3 to the x power equals 81, all right? Now I have on here in this little visual, all right, 3, all right? 3 is your base, all right? Notice 3 is your base. X is your exponent, and then equals 81, and this is what you are evaluating. This is what you get as your answer. Now, since exponents and logs are inverses, we can convert one to the other. So now this is kind of a two-way street, all right? So we're going to take what we're familiar with, exponents, and we're going to convert it to a log. Now, logs, when you write logs, you always just write log, log, and then you're going to utilize this portion. This portion right here, this is really like the exponent part, right? But you have to write log first, okay? So let's go back and see what this really is talking about, okay? So when you write it, notice it's log, and then it said this, log base 3. That's how you say it, log base 3. So I'm going to get my colors to match. So log base 3, and that is a little 3, all right? It's called a subscript. So log base 3 of 81, so notice 81, the 3 of 81 equals your exponent, x, all right? So I'm going to write it out how I set it, okay? So how this looks is this. You say log base 3, so whatever the base was of your exponent, that's what it is. So log base 3 of, now what your exponent actually equals, so in this case 81, equals x. That's how you say it. That's what this means, and that's how you would say it in words. So log base 3 of 81 equals x. So when we do this, it's important that you think of this so you know what the base is, so you know where values go. Of 81, that's what your exponent equaled. And then in a log, when your log is being evaluated, the value that it equals, so in this case x is the exponent of the original exponent that it could be transferred back at. All right, so we're going to get some practice going back and forth with this, starting as exponents, turning to logs, and going from logs back to exponents, because that's a huge, 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 huge property. Now, all right, something before we start rewriting, all right, is talking about two things, all right? Common logs and natural logs, all right? Now, common logs are logs that have a base of 10. And a base 10 means it's a subscript. It's that little number, that subscript of 10. And it usually is written as follows. So ready? I'll give you an example of what a common log looks like. Ready? Log of 12. So log 12. And you're like, log 12, wait, where's that little number? Where's that? Well, if you saw log 12, if it's log 12, it's called a common log. They're actually it really looks like this. Log base 10 of 12. This, anytime you don't see a value here, it actually is the number 10. All right. In all logs that you don't see a little subscript, a little base, it is always 10. All right. This is called the common log. So we're going to get some practice seeing that, seeing just a log of a number and being like, whoa, 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 where's my base? It's always 10. If you don't see it, it's 10. Now, natural log, that has a base of e. So if you remember before I said in class, natural log on your calculator, you're going to look for the button L, well, really it's like this, ln, all right? It means in the reason it's ln is it's Latin for log natural, all right? I don't, or log natural, all right? That is a Latin term for natural log. So they just kind of write it in reverse. But the base of this is going to be e. So for instance, all right, if you were to see, let's say, ln of 15, ln of 15, notice there's no base here. There actually is. It really is ln base e of 15. So the reason I show you this is that these two types of logs, common log and natural log, there's always going to be a base. There's always going to be that little subscript number. But for these two situations, log, just normal log, all right, which we'll see often. If there's no number here, it's always base 10. ln will only have base e. That's the only base ln or natural log will ever have. So if you see ln, it's always going to be base e, okay? So just wanted to make sure that we touch on that before we start rewriting. So what we're going to do now is we're going to convert and switch exponents into logs. So we're first going to go from exponential form, what we're most familiar with, and we're going to go and convert it into a new form, logarithmic form. So, all right, let's go and do that. So this right here says a to the y power equals x. So a to the y power equals x. So when we convert it to a log, we're going to write it like this. So when I say this, always in my head, I always say log base dot dot dot. So it helps me know what number needs to go where. So when I write this log base, well, the base of this exponent is a. So I start with this log base a. And then we say of is what it equals. So it's going to be log base a of x. And then now this log is going to equal always your exponent. So that's how you convert exponents into logs. Log base a of x equals y. So we're going to do it again. Ready? So I'm going to convert 3 to the 4th power equals 81 into a log. So I'm going to say log base. Well, what's the base of this exponent? Well, it's log base 3 of 81. That's what my exponent equals 4. All right? So now I want you to try these next two right here. You're going to try these next two. Pause the video and see if you can do these next two. Play it when you're done. All right, here we go. Ready? So this next one, All right, 2 to the 5th power equals x, so it should be log base 2 of x equals 5. And then the one below, log base x, because x is our base now, of 12. Oh, get out of your thing. I don't know what that is. Come on. All right. Log base x of 12 equals 6. All right. So again, always this, whenever you set this up, this is always your exponent of the exponent. All right. What logs equal will be the exponent. All right. It's always going to be that. So just make sure. And again, it comes from practice. Now, this last one, all right. Now, this last one is e to the negative third power is approximately 0.5. Well, as soon as you see e has to be ln. ln is the only log or the only type of log that will take the number e into it. So we have to write it as natural log. Notice all of these are logs. These are natural logs here. So we're going to go natural log of base e of 0.05 equals our exponent of -3. All right. So one thing that you can do also, and you're going to see, is really whenever I write this or you'll see a problem, I actually won't write base e. I'm just going to write it like this. Natural log of 0.05 equals -3. These are both the same. All right. Now, I know for the beginning, a lot of us are always going to want to write a base. You're going to want to see a base. But what we're going to want to get in the habit of writing it without a base. You can write it with or without, it doesn't matter. But know that there's always this invisible e here. All right. And the base of that natural log is e. All right. So that is going from exponential to logarithmic. Now what we're going to do over here is we're going to go logarithmic to exponential. Now, if you're like, I think I can do this without Mr. Quammen talking, go ahead, pause the video. You do all the exponential forms and then play the video and see if my answer and your answer match, right? So for this first one, ready? Log base a of x equals y. So again, log base, we always want to be focused on the base. So my exponent, my big number is going to be a raised to the y, so what my log was equal to, and my exponent is going to equal x now. So it's a to the y equals x. And again, at any point you're like, I got it, pause the video, see if you can do it on your own. This next one, log base 6 of 24 equals x. So our base is 6, so it's 6 to the x power equals 24. All right. Log a1 equals 1 point. Now, this is a good one. All right. If you pause the video and you try it on your own, you're probably like, dang, I forgot how to do this one. Well, notice here there's no base. Well, there actually is. It's 10. So it's going to be 10 to the 1.91 equals 81. All right. Continue on. Now here, this is where we're going to start having some fun. And this is where the solving part will eventually come in. Notice now we have like a little expression here, x plus 2. That's cool. You couldn't solve this when we get to the solving point in this form, but you could solve it if you converted it to an exponent. And that's going to be like the whole idea when we get to the backside of these notes is, oh, if I just convert to something I'm familiar with, it makes solving way easier. So here we go. Ready? Log base 2 of x plus 2 equals 5. So we're going to go base 2 raised to the 5th power equals x plus 2. So think about it. This, by converting this to exponential form, you couldn't solve this. You couldn't put this in your calculator. But here, what you could do is you could put this in your calculator. This is 32 equals x plus 2. Subtract 2, and you can actually get x equals 30. This is actually called solving. So right there, if you got that, you understand how to solve logs because you first convert to an exponent and then solve. But this is really what I wanted you to do. Could you convert to this? All right. But again, look how we just solved, all right? And then lastly, ln of 148 is approximately 5. Well, remember you have base e. So we convert this, we say e raised to the 5th power will be about 148. Now again, I put about because it will never, e is called an irrational number, meaning it never ends. So any answer of e will never come out as a perfect whole number. All right, so in this natural log, they gave you an approximation of 148. If you were to put this in your calculator, you would get very, very, very close to 148. not perfectly equal to it. Okay? So what we got now, all right, is a pretty good understanding, I feel, of logs and exponents. Let's flip over and let's start doing some evaluating, all right? Now, so now what we're going to do is we're going to evaluate. And this is where everything gets a little crazy, right? Kids are like, evaluate. What does that mean? Evaluate means give, oop, I can't spell right now. Give the numerical value, right? So like, what is the value of this log? Now, if you look at your graphing calculator, if you're like, oh, I could actually put that in my calculator, all right? And you're like, all right, log base 4 is 64. When you do that, all right, look this, log, notice when you type in log, log doesn't give you a base. Now, some of the new calculators will, there's a button that will do it, and I'm not 100% sure if actually the new calculators will put the base in there, but in the old school calculators, there's no base, which means the base of all logs that you touch are base 10. So you can't put this in log base 4 is 68 or 64. So instead, you're like, all right, I can't do it. I can't evaluate in this form. So what I'm going to do is I'm going to convert it to an exponent. So the first thing we're always going to do is convert to exponents. All right, that's what we're going to want to do. Convert to exponents. Now, when you convert to exponents, you're like, all right, theoretically, the exponent property is this: a to the m power equals n. Well, if you're like, okay, if you remember, there's supposed to be that equal sign. Notice here, is there an equal sign? Nope. Now, a to the m equals n. So this is really log base a of n equals m. So this is actually, if you were to look this up on Google, this is how they would probably show it like this. So what we're going to do is we're going to start with this, and we're going to go back and we want to convert it into this form. So the big thing is, notice there's no equal sign. There's no equal sign here. So what we're going to do is we're going to convert to exponents by making an equal sign. So we're always going to do this equals, all right? And we're going to do equals, and then I always put this box, all right? So this box is going to be our value that we're going to solve for or use or do some evaluating property from, all right? So whenever we do this, we want to make sure that we put this equals box whenever we're evaluating, okay? So now back to problem one. If I want to figure out what log base 4 of 68 is, I put equals box, and now I convert to exponents. So to convert, I'm going to go 4, base 4, raised to the box, equals 64. Now this right here, this I could have given you this problem in math 1 and said, all right, 4 to what power gives you 64? Right now, you could put this in your calculator and do something called guess and check. You could go, all right, I'm not familiar with what this is, but maybe it's to the second power. 4 to the second, oh, that's 16. So I tested out again. 4 to the, let's try third power. Oh, that's 64. So this box, this equals 3. You see that? So that's what this entire thing equals. So I always put like box equals 3, but theoretically, log base 4 of 64 equals 3. All right. So one way that math teachers try to get kids to learn how to evaluate is turn this into an actual equation. So for this next one, log base 7 of 49, we'll put equals box there. You want the equals, all right? So now we're going to convert to an exponent. So we're going to go 7 to the box equals 49. And you're like, all right, 7 to what power equals 49? Well, the box is going to equal 2. 7 to the second power, if this were a 2, 7 to the second power, that's 49. All right? Now, some of you are like, I'm pausing this and I'm going to go ahead. Well, a lot of these are kind of unique, so I would just say I'm going to go quick, and I just want you to see all these different variations of this, okay? So the next one, all right, ready? Log base 5 of 0.2. So I'm going to put the equals box here, and now I'm going to convert it. 5 to the box equals 0.2. Now, when you do this, you're like, oh, okay, good thing I didn't pause because this looks a little crazy. What I would ask you to do is let's convert this into a fraction. Now you're like, I don't remember how to convert that to a fraction. All right, well, your calculator does. All right, 0.2. And how you convert this in fraction, all right, is you hit math, frac, and notice I had to hit answer first. I had to type this into my calculator and have it absorb it into the brain. So notice made sure I hit 0.2, hit enter, and then I go math frac, and this is really 1/5. And the reason I want you to think about it like that is, look at this. 5 to the box equals 1/5. So think about this now. Let's think about our exponent properties. 5 to a power gives me a fraction. How do we turn a whole number into a fraction? And some of you at home are probably yelling at the screen saying, negative exponent. And you were right. Anytime you were taking a fraction and trying to make it a whole number, or a whole number to turn into a fraction, this number is going to be negative. Okay? So you want to think, 5 to what power is going to give me 1/5? Well, that's going to actually mean that the box is going to have to equal -1. All right? Because think about it. This, in order for 5 to go to the denominator, this exponent's got to be negative. And since it's not changing this 5, it's got to be -1. And if you're like, what? That doesn't make any sense. Well, try it here. 5 to the negative first power equals 0.2. And 0.2 is really a fifth. And you're like, oh my gosh, I see now. All right, so you have to kind of start remembering, or continue to remember, your exponent rules and your exponent properties as you work through logs, okay? So here we go. Let's go to the next one now. Number 4. Ooh, look at our base is a fraction. So now, very similar to this one. Ready? So log base 1/5. So I'm going to go 1/5 raised to the, so we got to put equals box. So raised to the box equals 125. Now, all right, very similar thing. So if you remember when we were dealing with fractions and exponents, again, we're taking a fraction raised to the box. So how do we get this to become a whole number? Well, again, this is going to have to be negative. All right, so really just focus on this. So I would be thinking, all right, 5 to what power gives me 125? And that is actually 3. 5 to the third power is 125. But since it's not 5, it's 1/5, our box is actually going to have to be -3. All right, so if you test it out, all right, I'm going to go in parentheses 1/5, because always in fractions, I always put them in parentheses in my calculator, raised to the negative third power, and look at that, equals 125. Okay, so your just your knowledge and your familiarity with fractions and negatives, it just comes from practice. Okay, so here we go. Let's try a couple more. All right, I'm gonna try one more, but actually what I'm gonna do is I'm actually gonna jump to 8, and I'm gonna want you to try these ones on your own and see if you can pause and unpause and check this out, okay? But we're gonna do number 8 here. So check this out. We got this. It's gonna be equals box, because you always got to put that. So I'm gonna go 4 to the box equals a half. Interesting. All right, 4 to the box equals half. Now, all right, you might be saying to yourself, oh, I know what I can do. I know what I have to do here. All right, so first off, if you look, 4 to a power gives you a fraction. You're like, I know this has got to be negative. This has got to be a negative number. All right, so you're like, okay, so I'm going to focus on this number. Now, what we're going to do is we're going to pause, right? And I'm actually going to have you go, and I want you to look at this one, because I actually forgot. You kind of need 5 in order to do 8. All right, so here we're going to put equals box here. All right, and we're going to get this one. 3 to the box equals 6. Now, one thing, notice my box is starting to look like 0. Make sure it's a box. Some students will sometimes put like a smiley face or something. All right, make sure it's just not a number. It doesn't look very much like a number. I'm just a fan of this box thing. So here we go. Ready? 36 to some power equals 6. Now you're like, hold on. That's not a fraction, so it's not negative. And I'm not sure what it's going to be. But I do recognize these two numbers, 36 becoming 6. And you're like, hey, yeah, if I actually took the square root of 36, that would be 6. And ding, that's what this problem is trying to get you to look at. All right. When we were learning exponents earlier on in first semester, we learned that there is a conversion of roots, square roots. Square roots have an exponential value. They equal the exponent of a half. All right. Come on. Stop touching all this stuff. All right. So an exponent of a half. So really, in this problem, if you do 36 to the 1/2 power equals 6, this is the same thing as a square root. All right. So in our answer, our box is going to equal 1/2. but I want to show you what this is, okay? So anytime you want to use a square root or think, hey, a square root would be helpful, the exponential value of that is 1/2, okay? So, ready? We're going to go 36 raised to the, and again, fractions in my calculator, I always put in parentheses, 1/2 power. You're going to get 6. So fraction exponents are really the root value, all right? They're a square root, all right, that you can convert and use in exponential form, okay? So what I would like you to do now is I want you to try 6, 7, and 8, now that you saw this 1/2. So 8 we already got going. So think about these, all right, especially with 8. 4 to what power gives you 2? Oh man, we're thinking, all right. Pause the video and try 6, 7, 8. All right, so here we go. For this one, for number 6, I'm going equals box. So I'm going to go 22 raised to the box equals 1. Now you're like, wait, equals 1? How do we get that? Is that a root? No. Think about it. In exponent form, anything to what power gives you 1, that means our box has to equal 0. All right, so our box, make sure that looks actually like a box and not 0. But yeah, anything to the 0 power, remember, anything to the 0 power gives you 1, so that has to be 0. All right, that's what this would evaluate out to be. All right, and this one right here, log base 9 of 1/3. So I go equals box. So I'm like 9 to the box equals 1/3. So now we're like, oh, fraction. So think about it. 9 to become 1/3. So we're really going to square root, but notice it's a fraction. So the fraction means that this is going to have to be negative. And since we want to square root this, our box is going to equal negative 1/2. Because really what this means is this is negative, so it flips, but it's like a negative root. So we're going to take the square root, and then we're going to move it to the denominator, which is very similar to this one right here. All right, 4 to what power equals 1/2? Well, 4 and the base of 2, that's a square root. All right, so really our box for number 8 is going to be negative 1/2. And you're like, what? Why? Well, 1/2 power is a root, so the square root of 4 is 2, and then we need to make that go to the denominator, and that's why it's a negative. All right, so our box equals negative 1/2. And every time I keep saying, if you're like, why is he saying box? That means this entire value, whatever it is, this actually equals negative 1/2. Okay, so if you're like, holy smokes, this is kind of making my head spin a little bit, it's all good. We just got to keep practicing this. All right, so now, ready? This next part is called simplify. Well, theoretically, simplifying, all right, simplifying is basically what we were just doing. You're just going to condense this down. But now, notice the difference here in simplifying. You're going to have a variable in here. And that's really what this is. Because theoretically, some kids are going to learn that those top parts you can just put in your calculator, which is why we're going to have a non-calculator quiz. So I can see what you know and don't know in terms of converting one to the other. So the simplifying, you can't put this in your calculator. You can only just simplify. So I'm going to show you a couple of these, and then I'm going to want you to try them. So number 9, all right, so simplify, we're going to do the same thing. Put equals box, all right, and now we're just going to simplify this. So we're going to go 5 to the box equals, and then whatever our log is, all right, so in this case, it's going to be 25 to the x power. Now this one's a little bit different because you look at it, you're like, wait, it's not just like, I can't just, spit out an answer. I got to really think a little bit. So the simplifying portion is this. Sometimes when you're evaluating or trying to simplify two exponents, you're going to have to break them down using a common base. So if you think about 5 and 25, can you write them as a common base exponent? And you can. 5 to the box is going to stay, but 25 written with the common base of 5 is going to be 5 squared. But we have to bring this x here, so it's going to look like that. All right. Now, this is called, once you identify this, that holy smokes, they have a common base of 5, and you write this, we're going to do something called common base cancellation. Because since we're trying to simplify, in exponents, when you're solving exponents, working with exponents, if you have two exponents that are equal to each other, that have the same base, we can cancel out their bases to continue to solve. And this is going to be something as we move along in logs, this common base cancellation. If your bases are the same, all right, you're going to be able to cancel them out, okay? So what our value is going to be is box equals 2x. So it's basically like we just did, but we're going to have to use this common base cancellation here. Okay, let's do one more. You know what? I'm going to do this one right here, and then I'm going to let you try 10 and 11. Now look here. This is actually a exponent. So kids are like, whoa, wait, hold on. Exponent, how do we simplify this? Well, we do the same thing. Equals box. And now exponents, you're going to have to convert back into a log. All right, so think about it. So you haven't converted back to a log since the first page. So how you would do that is you would say, all right, log base 8 of, so it's going to be of the box equals, now check this out, our exponent. Our exponent in this case is a log, so it's going to equal log base 8 of x. Now you're like, okay, I got that. How do we simplify? Well, we can do common base cancellation too with logs. If your logs and their base are the same, you can cancel them out. So this, if we were to simplify this, this actually would simplify to x. That's what it would simplify really out to be. So really, this is what this entire thing would simplify out to be. It would simplify to be x there. All right? So that's what it would look like. So what I would like you to do now, all right, now that you saw that, all right, I would like you to try number 10 and number 11, all right, number 10 and number 11. So pause and try that out. All right, so if you were to do this, again, set equal to the box, all right, let me see if I can use my finger here, all right, so it's going to be 7 to the box equals our 7 to the negative 3x. All right, so notice common base cancellation. So our box equals negative 3x. I apologize, I'm using my finger so it doesn't really look like it. All right, and then lastly here, set this equal to the box. So we're going to get 2 to the box equals 64x. Now, this is a fun one. You might have to use your calculator to help you out here. So notice we can't do common base cancellation because these bases aren't the same. So we want to look, how do I rewrite 64 as a base of 2? So it's going to be 2 to the box equals, all right? Now, 2 to what power gives you 64? So it's 2 to the 6th power. So it'd be 2 to the 6x, common base cancellation of the 2's. So our box would equal 6x, which basically means that if we were to simplify this, it would actually just equal 6x. All right? Now, lastly, the last and final thing is solving. Now, solving, all right, solving is basically what we've just been doing. If your solving problem starts as a log, you have to go from a log and you have to convert it to an exponent, all right? The only way to solve logs is you have to make it an exponent, all right? So I'm going to do 9 with you, and I'm going to want you to try number 10. And you're going to be like, solving is so easy. And honestly, it is. It is because you've done all the hard stuff. All right, to solve a log, we're going to first convert it to an exponent. So the first thing we're going to do is we're going to do base 5 raised to the 3rd power, so equals 3, equals what we're taking the log of, which is x plus 1. And you're like, holy smokes, this looks just like the last problem we did, or on the front side, we did an example like this. And you're right. So what we're going to have to do in order to solve is we're going to simplify. All right, so now look at this. 5 to the 3rd power is 125 equals x plus 1. Subtract 1, and x equals 124. Now, I want you to try number 10, pause the video, and take a look and see if our answers are the same. All right, here we go. Ready? X to the 2nd power equals 64. So you're like, wait, what to the 2nd power equals 64? So in this case, it's going to be x equals 8, because 8 to the 2nd power equals 64. Now, here's the deal. All right, because this lesson was a little long, all right, if you have a little time, I would ask you to start working on worksheet number 4 in your white packet. This is what it's going to look like. I'd encourage you to check your answers. Again, this is a 2-sided page. There's a lot of problems on here. So what I would say is this, all right, if you're getting these, do half of them. I would do like literally do the evens. And if you got the evens, cool, you're done. If you need some practice, do the ones that you're still struggling with, all right, to do it all. I would do it all, but again, I know today with it being a unique day, if you can only do part of it because of time constraints, then only do part of it. But you do have a long weekend, so I would think you should be able to do all of it, okay? Have a great day, and I will see you when I come back to school next week. Bye-bye.